So when it comes to limits of trigonometric functions, it's very easy. So wherever x goes, take that value and put in the expression. All you need to do is take this value and you will put this value in the expression. So let's start with sine and cosine. Here, let's look at this example. It's better for you to understand. So here we have limit as x approaches p over 2 of sine 6x minus p. So here we will put my p over 2 instead of x here. So let's do that. It is sine 6 times. So this is sine 6 times p over 2 minus p. Okay. So this is this would be actually, I wrote wrong, I think, because this would be like this. It doesn't make sense otherwise. Sorry about that. Okay, let's continue. Here we have sine 6, so it's in the parentheses of 6 times p over 2 minus p. Okay, so from here we will simplify these two and we have 3p minus p. It is sine 2p, right? And sine 2p, when I draw my unit circle here, 2p is here and its sine is here, it's equal to 0, right? So it means that this limit is equal to 0. As you can see, it's very simple. You just take this value and then put this value in the expression, in the given expression. So let's look at the second example. Here we have limit as x approaches p over 6 cosine x minus square root of 3 over sine x minus 1. Same logic, we will put this value instead of x here. So let's do that. We have cosine p over 6 minus square root of 3 over sine p over 6 minus 1. Okay, so cosine p over 6, it's equal to square root of 3 over 2 minus square root of 3 over sine p over 6, it's equal to 1 over 2 minus 1. And this is all equal to, this is 2 times minus square root of 3 over 2 over minus 1 over 2, and this is all equal to square root of 3. Now let's see what happens when it comes to tangent and cotangent. So when it comes to tangent and cotangent, you should remember some rules from our trigonometry lessons. Okay, so as you can see here, we have the graph of tangent. So at the point minus p over 2 and p over 2 plus p over 2, tangent is undefined at these points. Why? Let's remember, because tangent is equal to sine over cosine, right? So cosine p over 2 is equal to 0. So number over 0, this is undefined. That's why it makes this tangent value undefined at these points. Okay, so what is its relationship with limits? And it means that at these points, this function does not have any limits. All you need to know is this. Okay, so at this point, this tangent function does not have any limits. When it comes to cotangent, it's the same thing, but at minus p and p, cotangent is undefined. Same logic. Cotangent is equal to cosine over sine, right? So sine p, this is equal to 0. So number over 0, it is undefined. So that's why undefined. So that's why at minus p, negative p and positive p, cotangent is undefined, and it means that at these points cotangent function does not have any limits. So you should know these two bullet points. Let's continue with these examples. In the first example, we have limit as x approaches p over 2 sine x over cosine 6x. So here we put this value instead of x in our expression. So it will become sine p over 2 over cosine 6 times p over 2, right? So sine p over 2, when I draw my unit circle here, p over 2, it's here, and its sine is equal to 1. So this is equal to 1. Here we have, when I simplify these two, it's 3. So we have here cosine 3p, right? So here 3p, this is bigger than 2p. So what we should do, we should find its principal angle, right? So how we do that? We subtract 2p. So from 3p, when I subtract 2p, this is equal to p, right? So instead of cosine 3p, actually I can write cosine p. Okay, so cosine p, so p is here, and its cosine value is equal to minus 1, right? So this is 1 over minus 1, and this is equal to minus 1. So let's look at our second example. Here we have limit as x approaches infinity, 3 over sine x over x. So same thing, we will put infinity instead of x here. So it is 3 plus sine infinity over infinity. Okay, this is not equal to infinity. Okay, sine infinity cannot be equal to infinity. Why? As you remember, our sine function, okay, it's between minus 1 and 1. Okay, when we look at our unit circle here, this is our sine line, right? And this is between 1 and minus 1. This cannot be equal to infinity. So which means sine infinity, this is also is equal to some number, okay, between minus 1 and 1. That's why this numerator is a number actually. This is not equal to infinity, okay? So this is a number. So since this is a number over infinity is equal to 0. So our answer is equal to 0.